Hey everyone, welcome to the class. Today we're gonna cover one important last topic for our circuits class. We're gonna go into op amps in saturation mode. So I have uploaded a folder on Canvas with all the op amp slides that we have covered in class. So you can go on Canvas, you figure out the topics there. But the one that I'm covering, we covered most of them. We covered the multi-stage, we covered the basics of op amps, we covered a lot that goes along here. But today we're covering it in saturation mode. I want you to pay extra attention to details for this class because it's kind of a little bit confusing at first. And again, if you have any questions, you're more than welcome to contact me, send me an email, or you can contact me in class on Tuesday and we can set up some time to answer all your questions. I mean, we just have one last week, so good luck with the exams and everything. I hope you guys do well in class. Just a quick reminder, please do the survey that is sent to you. I really need your feedback. I want to know how I did. This is we did one already before, but this one is for the final one. So please do it. Thank you in advance for doing so. So, what I'm planning to do right now is I'm planning to share I'm gonna share notes from my iPad, and I'm gonna also be going through the lecture notes there, but I'm gonna write the circuit and I'm gonna draw everything on here from scratch so that you guys can follow the entire way that goes through. So let me share my screen here. Okay, so you guys should be able to see my screen. And then if we did something here, okay. So again, this is op amps in saturation. And this is what I'm gonna start here. All right. Oops. Let me share my screen again. Okay. Here. Okay. So if we do first, I'm gonna start by going through a simple example first, okay? So if you have an op amp here, an ideal op amp, right? And you have some sort of a resistor here and another op amp here. Okay, this is the plus minus sign. This is the minus plus sign. And this is here connected to ground. This is connected to the voltage source, plus minus the ground. And this is 1.98 volt. This one here is connected to, actually, let's save some space. So I'm gonna move this all the way here, plus minus ground. This is a little bit complicated example, and it's kind of interesting. You have this here, you have this ground. So you have a 4.7K ohms, and you have a 3.3K ohms. And then you have a feedback resistor, as we mentioned how important these feedback resistors are, and we call it 30K. And this is 20K ohms, of course. Yeah, I think that's it. Okay. So there is a bunch of different things that we need to pay attention to here. The voltage of op amp 1, the V out of op amp 1, the V out of op amp 2. Okay. Another kind of some currents that we need to pay attention to is this one here. This, I'm gonna call it current of op amp 1, output op amp 1. And then this one here, which is this part. And this is the current of op amp 2. And then finally, this current here, which is just IF, the current going through the feedback. And then you have two currents here. This one is I 4.7K. And let's say this one is I 3.3, okay? So one thing that you want to pay attention to when it comes to saturation is the dual supply. So it's given that the dual supply is set to be plus minus 6 volt, okay? So that's what you pay attention to. So what happens is, okay, so you want to find the current across the 3.3 first. Let's try to find every current that we have here so that we can easily figure out the VOP. Well, one thing I'm gonna use pink color for example, to help you with this. Okay, so what is this one? What is voltage here is 1.98. So what is this one? It's 1.98 volt, right? So the voltage here is 1.98, and we're trying to find this, right? Okay, we can find the I3.3 simply by doing current or by doing KCL, right? By figuring out this current, it's 3.3 is equal to what? 1.98 minus 0 divided by 3.3k, and that equals to 0.6 milliamps. Okay? Okay, good. Now, if we're trying to figure out VOB1, VOB2, what is VOB2? Is the voltage across here, right? So you know that current here is 0, right? Because there is no current that goes in or out of this op amp. So I 3.3 is the same current as I 4.7, correct? Because that's the only way this current is flowing. There is no current going into the op amp up here. So VOB here is going to be some sort of a voltage division. If you want to do so, you can say to figure out 1.98, you have to multiply VOB2 with 3.3k divided by 3.3k plus the 4.7k. And so from here, you know, VOB2 is simply set to be 4.8 volt. Okay, so that's the first thing you want to set. So as soon as you get to this point, you just simply compare it with the VCC. Is my VOB less than the max value here, which is 6? Yes. Is less than the magnitude? Yes. If it is, that's good. Okay, so that's okay. That's perfect for me. Now I try to figure out the other one, the other output voltage, which is the VOB1. Okay. First, I will try to find IF, sorry. What is IF? It's VOB2 minus the voltage at this point here. What is the voltage at this point? If this is 0 volt, this point is also 0 volt, correct? Because it's an ideal, both of them are the same. So it's VOB2 minus 0 volt divided by the RF, which is 30k. So you get IF, and we know VOB, which is the 4.8 volt, so we can substitute it in, and you will get IF to be 0.16 milliamps. I think this is very simple stuff, right? This is everything, we know all this kind of stuff. Okay, there is no current here. We know that current here is equal to 0. So we know IF is the one that is going to travel all the way through here, correct? So IF is simply negative IOB2, right? Because IF is going this way, IOB1, sorry, not 2, is the one going the opposite direction. Okay, we can also figure out VOB1, right? Because what is VOB1 is the voltage here, and we know the current going through here. So we know IF, right? IF is 0.60 milliamps. So we can say the current across the 20k is 0 minus VOB1 divided by 20k is equal to IF, which is 0.16 milliamps. I'm gonna copy this down here, but I was writing it up there so that you can see where it is coming from. Okay, and from here we know VOB1 is equal to, let me get it, VOB1 is equal to negative 3.2 volt. If this is the magnitude of this, magnitude of 3.2 is equal to, is less than the magnitude of 6, yes. So why 6? Because this is our VCC, right? Is negative 3.3 between negative 6 and 6? Basically, yes. So we're good. We compare it to our power rate, so we are good. Saturation mode. So this is exactly what you guys know. This is what you guys do. This is what we did in class multiple times. But the problem here comes within. What if our VCC was different? So let me copy this circuit down. What if our VCC was not 6? What would happen? I showed you the graphs and how the graphs would look like, right? They will be cut off at the top and at the bottom, right? But what does that mean to our circuit? So let's try to paste. I don't remember how do I paste here. Can I paste? Oh no. Okay, you know what? I'm just gonna move it down there. Oh, sorry. I'm gonna move it down since we already know what's going on. Okay, I'm gonna move it here. We're gonna do the same analysis on the same circuit, but this time VCC is not. VCC here is not 6 volt anymore. So it's completely different now. VCC is not 6 anymore. Okay, so let's say VCC is positive, negative 4 volt this time. It's not 6 anymore. So I'll try to explain to you the procedure of what happens and how do you know you are in saturation. So first, we will solve the same thing we did again, okay? So we know this one is 1.8, so this one is 1.8 volt. So this one is 1.8, so I 3.3, the same structure, I 3.3 is equal to 9.8 minus 0 divided by 3.3k. And we know this is equal to the same thing as I 4.7 because there is no current flowing in, right? And so this is equal to 0.6 milliamps. Same stuff, nothing changed till now, okay? And then VOB2, we can do a voltage division again. So 1.98 is equal to VOB2 times 3.3K divided by 3.3K plus 4.7K. Those are the two resistors that we're doing a voltage division on. And then you get VOB to be what? Like what do we saw here? 4.8. 4.8 volt. Well, 4.8 is more than the max value that I had before. What does that mean? It means we were at now we're above, like we're trying to get above the saturation limit. We can't do that. This exceeds the limit of our VCC, which is 4. Now we have the op amp in saturation. So what do you do? Well, how do we change our calculations, right? Because we can't treat it at 4.8 anymore. We have a limit of 4. Do we just use 4? What do we do here? And the answer is simple. We will say it is, we're gonna set it to 4 volt. You would ask me, why 4 volt? Why not negative 4 volt? Well, the rule says a couple of things. Well, I mean, you're setting it to the limit, right? What is the limit? The limit is 4, so it's gonna cut off at 4. So this is called a guess. You're guessing it's gonna be at 4, right? So we're gonna guess it's at 4 and see how it goes. Okay, so now we're gonna say we're gonna limit VOB2 to be 4 volt only and redo our calculation again. Restart our calculations. What does that mean? It means now everything, all our calculation that we have done is gonna be changed. So if this is 4 volt, if this is now 4 volt, the current is different. I 3.3 is now, or I 4.7, R 4.7 is what now? Or actually, let's not think about it this way. Let's think about it as, give me 1 second, let me think about this. VOB2. So, okay, so the bottom of amp rail to 4. The voltage of the bottom of amp rail to, okay, we will have, okay. So we know there is no current going in here. There's no current going in here, right? So the current, which is I 4.7 volt, let's say it's the same current, right? This is the same current. So current here, I'm just gonna call it I1. I1 is basically VOB2 minus 0 divided by the sum of the two resistors, which is 4.7K plus 3.3K. We're gonna substitute the 4 volt. You end up with I to be 0.5 milliamps. You would ask me, why didn't I use 1.98? Because this is not valid anymore. You have to figure something out because now I will show you why this is not valid. Because now 0.5 milliamps, okay? So the current is 0.5 milliamps. We know there's no current going up here. The only current that we have is going through the 4.7 and through the 3.3. So what is the voltage here now? Let's erase this now. What is the voltage here? The voltage here is simply the current I1 times 3.3K, which is Um, sorry, which is, what is it? 1.65 volt. So what is happening is this is now 1.65 volt. The plus and minus now is different. Now V plus is not equal to V minus. Things changed now. What happens here? Well, the rule says, hear out the rule, hear the rule out first. If V plus is not equal to V minus, you will check if V plus is more than V minus, or if V minus is more than V plus. If V plus is more than V minus, you set your V out to be equal to V plus. And if V minus is more than V plus, you set your V out to be V minus. So you set the larger one. In this case, what do we have? We have V plus exceeding V minus, correct? What is V plus? 1.98. What is V minus? 1.65. That's the two values we got. So now VOB1 is equal to V plus, which is 1.98 volt. It's kind of different. It changes our perspective. Well, it's actually, well, sorry, no, I made a mistake. It's not equal to, okay, if V plus is more than V minus, it's equal to the plus VCC, sorry. And if V minus is more than V plus, it's equal to the negative VCC. My bad. So in this case, V plus is more, so V out is equal to plus VCC, which is 4 volt. Okay? So we assumed first that VOB is 4 volt, and we figured out VOB1 now is 4 volt. Does that make sense? You have to, again, you have to verify your guess. We guessed that this is 4. We said, well, it's 4.8, so I'm gonna cut it at 4. This is a guess. This is not 100% true. This is just a guess that you have. It doesn't mean this is true, right? So when you have VOB to be 4 volt here, it not make sense. Quick review. I feel like people are gonna lose where I am right now. Let's do a quick review, okay? Come back. Let's come back together. You solve the circuit normally, like the way you would. You find your VOB, your V out. You check your V out and compare it to VCC. Is it more than the VCC? Is it between the two VCCs or not? If it is between the two VCCs, you're good. Life is good. If it is not, you'll have to guess. You'll have to guess a number. You have to guess a max VCC or negative VCC. So we guessed 4 volt, but and then we solved through and we figured out on the top here that V minus now is not the same as V plus, and V plus is more. So we're gonna set this to positive VCC. This is a quick review of what we did, okay? But that doesn't make sense because now 4 volt, and it goes through. What are you doing with your op amp? Something is wrong. So we have to restart again and set VOB1 down to be -4. So we're gonna do the same thing. We're gonna calculate I1. What is I1? VOB2. minus 0 divided by the sum of the two resistors, which is 4.7k plus 3.3k. And this is now negative 4. So your I1 now calculation is the same thing, but negative 0.5 milliamps. Okay, good. So what is the voltage here now? Let's erase this. The voltage here, we had it as 1.65. Now it's negative 1.65 volt. So now V plus and V minus. So V plus now is 1.98. V minus now is negative 1.65. Okay. So wait, give me 1 second. Let me double check something. So again, V plus here is more than V minus, correct? So what does that mean? It means VOB1, which is the voltage output one here, is going to be set to what? Plus VCC. Plus because V plus is more. So now this is 4 volt. And this is negative 4 volt. Okay. Let's try to verify. Let's try to verify our answer here. I mean, we will need to figure out, okay, let's try to verify our answer. Let's figure out what is our IF first, okay? What is IF? IF is VOB2, right? IF here is VOB2 minus the voltage here. But what is the voltage here? Actually, let's think about it differently. IF is the current that goes through these two, right? So we can say it's VOB2 minus VOB1 divided by the sum of the two resistors, which is 20k plus 30k. Because again, there's no current going into the op-amp. So VOB2 is negative 4 minus 4 divided by 50k. So you get negative 8 divided by 50k, and you get negative 0.16 milliamps. Okay. Now we IOB2, which is this current here, IOB1 or B2? OB1 is, I'm gonna put it here. IOB1 is negative IF, right? Okay. This is this one. It's the opposite of IF. IOB2, which is the current here now. IOB2. We can do some sort of a KCL here, right? We know I1, which is the current here, and we know IF. So IOB2 is basically a KCL. Simple enough. Okay. So let's think about this now. What is the voltage here? It's 0 volt. What is the voltage here? The voltage here, I mean, we know the current, IF, which is negative 0.16 milliamps. The other way, so IOB1 is 0.16 milliamps. And so what is the voltage at the negative side here? Well, we can do VOB1 minus V minus here divided by the 20k is equal to 0.16 milliamps, right? That's the current, and then the voltage here minus the voltage here divided by the 20k. You get V minus to be equal to, what is it? Let me get the calculation. Which one is this? You get V minus to be equal to what? Wait, 20k times V minus, what is V minus? V minus to be 0.8 volt. So what is happening now? Which one is bigger in this case for the second op-amp? V minus is larger than V plus. What does that mean? It means VOB2 has to be set to negative VCC. And it is set to negative 4. That's the second assumption that we have. So we're good. That means we came through a full loop and it's correct. So when saturation happens, you cannot assume V plus is equal to V minus anymore. V plus and V minus will predict what VOB, what is the output voltage gonna be. If V plus is more than V minus, VOB is VC plus VCC. If the opposite, output voltage is negative VCC. So as you can see here, there's a lot of calculation, there is a lot of things happening, there is a lot of guess. You guess VOB2, you go with it, you see if it makes sense. If it doesn't, you switch it to -4, and when you come back, when you do a full circle back, remember that now you will check the V plus and the V minus for this one here. So if this, again, if the V minus here was what? Was more than the V plus. And so VOB had to be negative VCC. So our guess, which is the -4, the second guess, is correct. Does that kind of make sense? Hopefully it makes sense. This is very complicated and I totally understand. If you have questions, please contact me in class and watch this lecture a couple of times. You would need to watch it at least twice to 100% get what is happening. So again, contact me if you have any questions, let me know. And let's meet in class. Yeah, let's meet in class and see how it goes from here. See you guys on Tuesday.